Hello everyone, I am Abhishek Datta and you all are watching my YouTube channel Mathematics Made Easy. Today I am here to discuss about the basic concepts of a straight line in two dimension, that is on a plane. We can also discuss the theories of a line in three dimension, that is in space. But for time being, let us start our discussion with two dimension. Then we can carry forward our discussion to the next advanced level, that is the theory of straight lines in space, that is in three dimension. Now whenever we talk about two dimension, we consider a plane. Two dimension means a plane. So how to define a straight line on a plane? So basically we can define a straight line as the locus of a moving point on a plane. Locus means the path along which a point travels. So say let us consider the plane of this board. So here we have a plane which is 2D, two-dimensional plane, and on this plane let us consider a point P which is a variable point. That is, this point is movable point, this can change its position. Now if the point P changes its position such that its direction always remains the same. So these are the successive positions of P. So as we can see, say the successive positions are P dashed, P double dashed, P triple dashed, and so on. So here the point P moves in such a path that its direction always remains the same. Then the locus of this moving point P, locus means the path along which the point travels. So this is the path if I join all these points. So this path or this locus of the moving point is said to be a straight line. So basically a straight line on a plane may be defined as the locus of a moving point whose direction always remains the same. This is how we can define a straight line on a plane, that is in two dimension. Now there are various concepts associated with a straight line in 2D. Let me discuss those concepts one by one. The very first concept is the idea of the slope of a line, or which we also call the gradient of a straight line. So what we mean by slope or gradient of a line? So if we consider our reference frame, the coordinate reference frame, that is our x and y axis, and this being the origin, and say we have a straight line on the plane named as AB. Let us consider this line AB on this plane. Now by the slope of the line AB, so to study the slope of this line AB, first we have to study the angle of inclination of the line with the x-axis. So what we mean by angle of inclination of a line? By angle of inclination of a line, we mean the angle which the line forms with x-axis in the positive sense, not with y-axis. Angle of inclination means the angle which a line forms with x-axis. We shall consider x-axis only in this case. So here this is the angle which the straight line forms with x-axis. Now in positive sense means in anti-clockwise sense, that is starting from the x-axis itself, if we move towards the line, then the direction which is anti-clockwise. So here this direction is anti-clockwise. So this is the positive sense or positive direction of the angle. So this angle measured in anti-clockwise direction is considered to be the angle of inclination of the line AB with the x-axis. Now here we also have an obtuse angle formed between the line and the x-axis, whereas here this angle of inclination is acute, as you can see from the figure. We also have an obtuse angle formed between the line and x-axis. But if we measure the direction of this angle from x-axis towards the line, the direction should be always from x-axis towards the line. then here the direction becomes clockwise. This is not anti-clockwise. So hence this angle cannot be considered as the angle of inclination by definition, because our definition is the angle measured from x-axis towards the straight line in anti-clockwise sense. That angle is considered to be the angle of inclination of the line with x-axis. Now it is not necessary that the angle of inclination should always be acute. As from this diagram, such a case is not necessary. The line may have an obtuse angle also. If I consider another line, say CD, likewise here another straight line CD. So here you see, from x-axis, starting from the x-axis, if you move towards the line, so this is the angle in anti-clockwise sense. So here this angle is taken to be the angle of inclination of the line CD formed with x-axis. And if I name this angle alpha, so as you can see here that alpha is an obtuse angle, whereas in the previous case theta was an acute angle. So the angle of inclination may be acute or it may be obtuse, but the main point is the angle should be measured from the x-axis towards the line in anti-clockwise sense. Now once we have the angle of inclination of a straight line, if I consider the trigonometric tangent, trigonometric tan value, tan of theta of this angle, tan theta, where tan is the trigonometric tangent ratio, then this number tan theta shall give us a number of value. So if I call this number m, then this number is said to be the slope or gradient of the line AB. So here we are discussing about the concept of a slope or gradient. Sometimes slope is also known as gradient. So by slope or gradient of a straight line, first we have to find the angle of inclination of the line, that is the angle formed by the line with x-axis in positive sense, in anti-clockwise sense, and consider the trigonometric tan value of that angle. Then this tan theta, value of this tan theta denoted by m, so this will be a number. So this number is said to be the slope or gradient of a line. So thus with every line, with every straight line, we can associate a number m which can represent its slope. Now for example, if I consider a straight line parallel to x-axis, say this is x-axis and y-axis, and here we have a straight line parallel to x-axis. So if we are to determine the slope of this line, so first what we have to do, we have to find the angle of inclination of the line with x-axis. So between two parallel lines, no angle is formed. Since our line L, if I call this line L, is parallel to x-axis, there is no angle formed between the line and the x-axis. So no angle means mathematically the angle is 0 degree. So here the inclination is taken to be 0. So hence the slope of the line M is given by tan of 0 degree, which is also 0. So thus for every straight line parallel to x-axis, its slope is given by 0. This is a very important point, that whenever we have to prove that a line is parallel to x-axis, it is sufficient to show that its slope is equal to 0. Similarly, if we have a line parallel to y-axis, let us now consider another straight line parallel to y-axis. Then to find the slope of this line which is parallel to y-axis, so again we have to determine the angle of inclination. So since the angle of inclination is formed with the x-axis in anti-clockwise sense, here we see that the angle of inclination here is 90 degree pi by 2, because since the line is parallel to y-axis, it is perpendicular to the x-axis. So here theta becomes pi by 2. So tan pi by 2, we know tan pi by 2 is undefined. We can say this tends to infinity, or it is undefined basically. So slopes of lines parallel to y-axis basically becomes undefined. That means if we have a line which is parallel to y-axis, its slope cannot be found. So it is not that every straight line has a slope, there are infinitely many lines on the xy plane which are parallel to y axis. All those lines will have no value for their slope because their slope value is tan pi by 2, which is undefined. But for any line other than the lines parallel to y axis, all other lines will have some slope value. Let us consider another example. Say we consider a line. Let us now consider the bisector of the first quadrant. If I consider the bisector of the first quadrant, and let us try to determine the slope of the angle bisector. So here we have our reference frame, x and y axis. This is the origin and this is the bisector of the first quadrant. So here the angle of inclination with x-axis is 45 degree because the entire angle is 90. This line being the bisector, it makes an angle 45 degree with the positive direction of x-axis, that is with the anti-clockwise direction of x-axis. So this is the angle of inclination theta. So the slope value m is thus given by tan of 45 degree, which is equal to 1. So in this way we can find the slope of any straight line whose angle of inclination is known. Next is the relation between the slopes of two parallel lines. How to determine the relation between the slopes of two parallel lines? So let us consider two parallel lines. Say this is our x-axis here, and let us consider two parallel lines on the plane like L1 and L2. These lines are given to be parallel, and we have to establish a relation between their slopes. So again, if I consider their respective angles of inclination, so say this one is angle theta 1 and this one is angle theta 2. Both the angles are measured in anti-clockwise sense from x-axis towards the line. So from this diagram we can see that as these two lines are parallel and x-axis acts as a transversal, so these two angles being the corresponding angles, they will be equal. This is the property of parallel lines, that whenever two lines are parallel and we have a transversal, the two corresponding angles are equal. So here we have theta 1 is equal to theta 2. So upon taking trigonometric tan ratio over both, this gives us tan theta 1 is equal to tan theta 2, or which gives us m1, which is the slope of the first line, becomes equal to m2, which is the slope of the second line. So thus, whenever we have two straight lines which are parallel to each other, their slopes becomes equal. So whenever we have to prove that two lines are parallel, it is sufficient to prove that their slopes are equal. Next we come to the discussion of finding the slope of a line when two points on it are known instead of the angle of inclination. So to find the slope of a line, when the theta is not known, the angle of inclination is not known, but instead we have the coordinates of 2 points on the line, then how to find its slope? So let us consider our reference frame as x and y axis, and say here we have a line like this, and 2 points on the line are known as p x1 y1 and another point q, say x2 y2. So we have the coordinates of 2 points p and q on a line. So we have to find the slope of the line in terms of these coordinates x1 y1 x2 y2. So how to do so? For that, let us drop two perpendiculars from the points P and Q upon x-axis. Say the perpendiculars are PM and QN respectively. This is our origin. And also from P we drop another perpendicular, say PR over QN. So these are the constructions. Now OM, from the diagram we see OM is given by x1 because OM is the abscissa of the point P, which is x1, and PM is the ordinate of the point P, which is y1. Similarly, ON is the abscissa of the point Q. This length ON is the abscissa of the point Q, which is given by x2, and QN is the ordinate of the point Q, which is given by y2. Now let us mark this angle as theta. So this is the angle of inclination of the line PQ with x-axis. This is the angle of inclination. And as we can see from the diagram that the line PR is perpendicular to x-axis because QN is perpendicular on x-axis and PR is perpendicular on QN. So hence PR is parallel to x-axis. So this angle QPR, will also be theta because these two angles have corresponding position, and since these two lines PR and the x-axis are parallel, the line PQ acts as the transversal. These two angles become equal because they are corresponding angles. Now if I focus our concentration on this rectangle PMNR, let us focus our concentration over this rectangle. Now see what is MN. MN is given by ON minus OM, and from the values here we have, this is given by x2 minus x1, and so is the length of PR. Why? Because PMNR is a rectangle by construction, so opposite sides of a rectangle are equal. So MN is given by x2 minus x1, which also becomes equal to PR. And similarly, we have PM is given by y1, so Rn is also y1, being opposite sides of the rectangle. So we have PM is equal to Rn is equal to y1. So therefore QR, if I now consider this length QR, so QR is given by Qn minus Rn, which is given by y2 minus y1, because Qn is y2 from here and Rn, this is equal to y1, so QR becomes y2 minus y1. Now if I consider this right angle triangle PQR, so in this right angle triangle PQR, what is the value of tan theta? Let us concentrate on the value of tan theta in right angle triangle PQR. So tan theta is given by perpendicular upon base, which is QR upon PR. So this is given by QR upon PR, and upon substituting their values, QR is given by y2 minus y1 upon PR is given by x2 minus x1. This is the value of PR, x2 minus x1. This is QR, y2 minus y1. And tan theta is nothing but the slope of the line PQ, as we have discussed earlier. Theta being the angle of inclination, its trigonometric tan value is nothing but the slope. So this is the value of M in terms of x1, y1, x2 and y2. So thus, when we have 2 points on a line with known coordinates, then its slope can be found by this formula given by y2 minus y1 upon x2 minus x1, even if the angle of inclination is not known. So the slope of a straight line can be found if either the angle of inclination is known angle of inclination of the line with x-axis is known, or coordinates of 2 points on the line are given. So far we have discussed about if I recapitulate our discussion, so far what we have discussed: the concept of a straight line in 2 dimension, the concept of angle of inclination of a straight line, concept of slope of a straight line. We have also discussed the slopes of certain straight lines, likewise parallel to x-axis, lines parallel to y-axis. For example, for lines parallel to x-axis, their slopes are 0. For lines parallel to y-axis, their slopes cannot be found. The bisector of the first quadrant, it has the slope 1. And also we discussed the relation between the slopes of 2 parallel straight lines, that whenever 2 lines are parallel, their slopes are equal. And finally we discuss the process of finding the slope of a straight line whenever 2 points on the straight line are known instead of the angle of inclination. Next we shall discuss about the equation of straight lines. So that we shall be continuing in our next video. I hope the concept of a straight line in 2D and the very basic concept of slopes of a line are clear to you all. If you have any questions regarding to this, you can ask me in the comment section, and let me carry forward this video to discuss the equation of a line, because the video will become much lengthier. So we shall take up that topic in our next upcoming video. Thank you all for watching.